Hello, Tom from Every Step Physics, EveryStepCalculus.com. A physics problem. This person sent me their test and wanted me to show them how my programs work on their test. And so I'm going to do a series of videos on that test. This is an example of what was in that test. You can see it. A hypothetical planet has a mass of 5 times e to the 23 kilograms and radius of 3 e to the 6 and no atmosphere. A 10 kilogram space probe to be launched vertically from its surface. If the probe is launched with an initial energy of 5 times e to the 7, what will be its kinetic energy when it is 4 times e to the 6 from the center of 0 of the planet? And this is, they're asking for final kinetic energy. In physics, there's initial velocity, final velocity, initial height, final height, initial kinetic energy, final kinetic energy. And so I'm going to do these two problems here quick for you. Press enter to get to my menu. As you put, you can buy my programs, of course, at EveryStepPhysics.com. It's only $30, and you can pass your physics class, okay, and do your tests, maybe some homework and stuff like that. I try to do what I tell you to do when you buy my programs, is to put a box around what they're asking. Kinetic energy here, they mean final kinetic energy, and then you put the variables off to the side, like mass 1 is equal to 5 times e to the 23. You have to press that double E button on your calculator and put the radius in, and I'll show you how that works. We're going to scroll down here, but certain things in things like baseballs would be a certain thing in my menu, grouped like that. Bow and arrows. So you have to get used to my programs, kind of logically get used to them, but I think they're pretty simple. I mean, how would you do it? We're going to press the cursor down here and go down. You can press second on your calculator, this second button here, hold it down and press this, and you'll go screen by screen to get to it's all alphabetical, so I'm going to go down to the P section here and choose planets. And here we are here. And here's the menu for planets, okay, and we're asked to find the final kinetic energy, so here's number 7. You can press the numbers before that or scroll down to it. There's scrolling. I'm going to press the number 7 now, okay. And we're find final kinetic energy, given maximum distance, etc. You can read that. Kind of sets you up that you know you're in the right program. I give you the gravitational constant, which is this is Newton's invention here, 6.67 times e to the minus 11. This is scientific notation, of course. We're going to enter the planet mass, okay? So you have to press alpha first. Alpha, what was it? 5 times e to the 23. 5 times, and then press this double E button here, and 23 kilograms, okay? The probe mass is given as alpha 10. I always give you these conversion choices because physics professors and problems love to trick you and see if you know what you're talking about. You'll notice that this has nothing to do with physics, this problem. They're really just a problem using algebra to figure out this stuff and putting variables in and doing the math correct. And we certainly know we can screw up that if we don't do it correct with minus signs, etc. Enter the radius. What is the radius? Alpha 3 times e to the 6. 3 times e to the 6 meters. And initial kinetic energy is what? alpha 5 times e to the 7, alpha 5 double E 7. The distance given then is 4 e to the 6, alpha 4 e to the 6 meters again. I always show you what you've entered. You can change it if you want. If you've made a mistake, say it's okay. We do the calculations. Here's the gravitational energy here, minus sign in front, of course, and then times 1 over the radius of the planet, minus 1 over the distance, plus the initial kinetic energy. I add the variables here. Here's the variables. And 1 over 3.6, 1 over 4.6, and then the kinetic energy is here. And we do the calculation just like you would on your paper. You write everything you see down here. Here's the gravitational energy here, calculated with the mass and the probe and the constant, gravitational constant, etc. And we're adding the initial kinetic energy here, etc. We do all the math, subtracting this 2.5 from 3.3 here to get 8. Okay. And the answer is 2.22 to 5 decimal places times e to the 7 joules. All right. Now we go back for a new problem. We can go press number 1. We're back here. This one was number 2, maximum distance. Launch from this. Now we want to find the initial kinetic energy. We put a square box around what they're asking for, so you don't get confused. Every problem is the same in physics. They ask you for something. You put a square box around that, and then you go to the side of your paper and you put down the variables. Like here's mass 1, here's the radius 1, here's the probe, etc. So I'm going to do this in another video. It's number 2 here and coming up. So go to my site, buy my programs, and pass physics. Physics is unbelievably difficult and mostly to do with algebra and math to solve the problems. And the conservation of energy and all that never helped me. I had to memorize the formulas and stuff like that and be able to place them into the test. All right, so have a good one.